our first part of conversions here, just kind of giving you the basics, how we set these up, how I want you to do them, and then a few examples. So first thing we need to talk about is, okay, what the heck is a conversion factor? Kind of alluded to them a little bit with the metrics that we talked about with the SI system. What a conversion factor is, it's a ratio that expresses equal values or equivalent measurements or quantities in two different units. So that this allows us to convert from one set of units to the other. That's why we have two separate units. Something you've seen before, just start off with something you know, and then we'll apply it to some new stuff. But how many inches are there in 1 foot? Well, okay, 12 inches equals 1 foot. How we write that as a conversion factor, we do need to write it as a ratio for what we want to use. So as a ratio, I can write it as 12 inches divided by 1 foot. So ratio is a fraction. Or the other way. But the whole idea is that they're equal values. So yeah, 12 inches equals 1 foot. 1 foot equals 12 inches. And that's important that they are equal. If I were to have 1 inch and 12 feet, the numbers are the same, but as far as what units they go with is not. Those are no longer equal. It's no longer a valid conversion factor. For something like this, that's easy to say, oh, I know how to do that. But when we get to the metric system, the SI system, that's an easy mistake to make. How I expect you to do your conversions, you may be able to do them different ways, but how I want you to show your work, how I expect you to show your work, is using the factor label method. The reason why is we're going to use this a lot in chemistry, especially when we get on to further chapters, and the reason why I want you to do this, because it allows us to keep track of our units. And it's a good organizational tool to do that. So factor label method, you'll hear me call it dimensional analysis, you hear me say train tracks, it all means the same thing. And again, it's just a way to set up conversions and keep track of those units or labels. So example 1, we'll start off with something you know how to do, but show you using this dimensional analysis train track method way. So convert 40 inches to feet. First thing you want to do is just start off with whatever you're given. So the only number we're given is 40 inches. Notice I put a label here. It's very important because the whole idea of this is to keep track of those units. And then we draw some train tracks. We're going to start off with something like this. Sometimes you may have 2, 3, 10 of these. I think for later on we get up to 6. So it becomes really important to keep track of them, of those units. So we're going to write them in next. What I want to do next is, okay, can I convert inches to feet? Can I do that in one step, or is it going to take multiple? I can do it in one. And what's that look like? Well, I know that using this method, I want my units to cancel. So if inches are up top here, I want to put them opposite. If they were on bottom, I'd still put them opposite, just they would be on top over here. And then I'm trying to convert to feet. So that's my other set of units. Now I need numbers to fill them in. Okay. 1 foot is 12 inches. That is a proper conversion factor. Those are equivalent. Next thing I look at it, and okay, inches are now gone. Don't have to worry about them. Completely eliminated. The only thing I have left is feet. Well, that's what it wants my answer in. So that means I'm done with my dimensional analysis. In this case, it was just one step. Some of you may be asking, well, Mr. Saker, there's a blank spot here. You can leave it blank, or you can put a 1 in. It really doesn't matter. And then you solve. To solve this, what it actually looks like, or how you're actually going to type it into your calculator, is going to be 40. And anytime you see a vertical line, that means multiply. So 40 times 1, and then I ran out, so I go to the bottom. Well, if it's on bottom, so horizontal line, that means divide. So in this case, now that I have a 1 here, divided by 1, divided by 12. I put the ones here in here to show you just what we're doing. You don't need them when I actually type this into my calculator. I'm not going to type the ones in. But when I do that, I end up with 40 divided by 12, which comes out to be 3.33 repeating. And then last thing, what's my label? Because is this 3.33 squirrels, birthday cakes, whatever? Well, in this case, we're talking about feet, so make sure you do finish with the label. So there is your answer. Number 2, again, something else you know, but I just want to kind of show you it's not always going to look like this. Convert 6 feet to inches, so a little quicker this time. Start with whatever number that's given. In this case, it's 6 feet is the number we're given. Can I convert feet to inches in one step? Yes, I can go directly from here to here. So let's do that. Again, need one set of train tracks. I want to get rid of feet, so I'm going to put those on bottom. I'm trying to convert to inches, so those go up top. Next step, fill in my numbers here. Well, 12 inches is 1 foot. Feet are no longer there, don't care about them. Left in inches, that's what it asked my answer for. So we're good in terms of setup. That's what's nice about dimensional analysis, is that it lets you know, hey, you should get the right answer as long as these numbers are correct and you type in your calculator correctly. So ready to input our answer. If it's on top, we multiply. If it's on bottom, we divide. So 6 times 12 divided by 1. Again, you don't need it. Plug that into your calculator and you get 72 with a label inches. And then answer with a label. Example 3, a little more wordy, but kind of the same process. So given that there are 5,280 feet, so that might be something I need, in 1 mile, how many inches are there in 26.1 miles? So I'm given some numbers here. I got to figure out just what it's starting with, and then what the heck does this other stuff mean? Well, it looks like this is a conversion factor. It's telling me that there are this many feet in 1 mile. And if you didn't know this, a good way to remember it, just kind of a side note here, 5 tomatoes. Five tomatoes. But back to the problem here. So this is the number we're going to start with. We want to know how many inches are in this many miles. So let's start there. 26.1 with the label miles. Now can I go directly from from miles to inches? Not off the top of my head, I don't know how many inches are in a mile. So what's kind of an intermediate? Well, we could go from miles to feet, and then once we get to feet, we could go feet to inches. I know how to do that. And then it gave me this conversion factor, this many feet in a mile. So this one's actually going to take 2 steps. So 26.1 miles. First step, well, I don't want miles because I want my answer to be in inches. So miles, I want to cancel, so they go opposite. And then this first step, I'm trying to convert to feet. We said there were 5 tomatoes, 5,280 feet in 1 mile. And again, that makes sense. 5,280 miles is not 1 foot. So I do have it correct. That cancels miles. Don't care about them anymore. Now we have just feet. So last step to get to inches, another set of train tracks here. I want feet to cancel. I want to end up in inches because that's what it's asking, how many inches. So how do I get this to cancel? 1 foot, 12 inches. Feet are now gone, left with inches. In my calculator, this is going to be, I'm going to have to write small here, 26.1 times 5280 times 12. Divide by 1, divide by 1. I'm not going to write that. But when I do the math here, I get 1,653.696, and my label is inches. Sig figs. Which one of these are actually significant? Here, most problems, it's probably going to be what you start with. So what number you're given will determine the significance, because this is a given factor. It's always going to be that. It's exactly that many. Same thing here. So there's actually infinite sig figs for each of those. So let's go to 3. 1, 2, 3. The next number is a 3, so I'm going to round down. 1, 6, 5. And then we said that 3 we were rounding down. Show magnitude, don't forget those zeros, inches. That right there is our final answer. 2 steps, same process though. Make sure your units cancel. So opposite, make sure your conversion factors are written correctly. Multiply across, divide by what's on bottom. If it's a 1, you don't have to do it if you don't want to. And then make sure your answer has a label. Alright, last example. This one probably easier than the last one. I just wanted to show you an example like this because sometimes I give you the conversion factor and then I just expect you to know how to use it from there. So convert 3.45 pounds to grams if 1 pound equals 453.6 grams. So that would be the problem. I then started with this. So write this conversion factor as a ratio. So I did that first, and I have 2 ways. Well, which way am I going to use? I don't know, at least right now, but let's start the problem. The setup will tell us which one we're going to use. So number we're given in units, 3.45